Welcome to another Earth Engine tutorial. In this video, I'm going to show you how to get image properties and how to calculate descriptive statistics. For example, how to get the minimum value, maximum, and average sum, something like that, of an Earth Engine image. Let's get started. So first of all, you need to install the GEmap package and make sure that you install the latest one. If you have installed this before, you need to update to the latest version, so 7.07.10, and you can click here the installation, how to update the package. You already installed this one before, and once you install and update the package, then you can go ahead and grab the notebook examples that I put on the GitHub. So notebooks, and this one is number 30. So you just click. You can clone the GitHub repo, or you can if you just want this one, you can click the raw button, and then from here just right click save as. And in here I'm going to save this one to my downloads folder on my computer. Hit save. Then you can open here, open your file explorer. Once we have the file, then we can start launch Jupyter Notebooks. So first I need to get into the downloads folder, and then I can conda activate the environment. Then you can type Jupyter Notebook to launch the notebook. It's open on your browser, and you just click notebook to open. So here there's some like basic examples. I'm going to go through step by step, show you how to get image properties using the traditional way, and how you can also use GEmap to quickly get all the properties and calculate descriptive statistics. So let's get right into it. First, you need to import the library, Earth Engine and GEmap. After that, you can create an interactive map. Once we have the map, let's add some data. So first, I'm going to add a Landsat imagery. So I'm going to choose a point location. You can customize these points if you want. Let's just execute, right? And we get a Landsat imagery around here in San Francisco, California. So this is Landsat 8 surface reflectance, and I use the point. So basically I have a point somewhere in here, and I filter the image collection using the point, and then I select just the first image because this is an image collection. So think about a bunch of images, and then I just select the first one. After that, I can customize how I want to show the image. Okay, so this is surface reflectance. So from 0 all the way to 10,000. It's rescale. So this is like integer, but surface reflectance is from 0 to 1. So we just need to divide this one by 10,000. So basically it's a reflectance. And then I'm going to show this one using band 5, 4, and 3. So this is force color composite. Okay, so that's why you see the red color here, and this is the first image that we're going to use. Secondly, we're going to add another imagery called net imagery. So net imagery is high resolution imagery within the US by the US Department of Agriculture, so USDA. And similarly, we're going to filter by this point location, and we're going to select the first image. Then we are going to show the force color composite similarly. So it's red, green, near infrared, red and green, and then we show the image. This one, take a look. So now we have these two images. This is the 1 meter resolution. You can compare this one to the 30 meter Landsat. Totally different level of details you can see from here. Once we have the data, now let's get some image properties. So how do we know, for example, from the Landsat data? Basically, we want to get some metadata, right? We want to know when this image was acquired by Landsat, and what's the spatial resolution, how many spectral bands within this imagery, something like that. And so how can we get the information? If you use directly OS engine, you can use the .get. But before you use this function, you need to know kind of the name of those properties. So you can use the property names to get the information. So the first one here, we use the variable called Landsat. So this is the image. So image dot property names, and then dot get info, because by default it's an OS engine object. If you want to print out the information, you always have to use the dot get info to get the information. So let's get one. And now you see here, these are about the image property names for this specific image. You can see from the list, for example, cloud cover, like system ID basically is a unique ID within the OS engine data catalog. And the Landsat ID, some of the information that you might interested in, for example, system time start and time end. So these two basically was when the imagery was acquired by Landsat sensor. So it's very important that we want to figure out when was this image acquired and how many bands within the image. What's the names of each band, something like that. And also it's its size. Right, you want to know how big is the file, how many megabyte. Once you know the property names, then we can use the .get. In this case, for example, if we want to find out what's the cloud cover for this image, you can image.get and then pass in the name of the property. So in this case, it's called cloud cover. So we can copy and paste in here and then .get info, hit one. So now you see this is 0.05. So basically, this image has 5% cloud cover. And similarly, if we want to find out, for example, when was this image acquired, you can always use this one, system colon time start. So basically, for each image, there is a starting point and the ending point. You can use this one to get the date. Maybe show you. Okay, so you see this like very big number, and so this is nobody can really figure out like what day it is because it's by second. So it's a number of milliseconds since 1970 January 1st. Okay, so in this case, we need to convert this one to for example, year and months and date format. How can you do that? You need to get this one and basically convert this number milliseconds to date, and then reformat this one as whatever format you want, and then .get info. Just hit one, and you see from here 2013 April 9th. As you can see from here, it's not very intuitive. If you are OS engine beginner, you might not know like exactly how to get this one, because you need a couple of steps together in order to get the date you want. So the information is there, it's just not like very intuitive. So that's why I provide some functions in here in the GEmap package that you can get. You just use one function, you get everything you need. If you go back to this example, right, in here we have maybe more than 20-30 like properties. If you want to get the value for each individual property, you need to get one by one. So .get and then the property names, and then you get the value one by one. But sometimes we might want to show all the property values all at once. Like how can we do that? So this is where you can use this function gemap.image props, and then within the parenthesis you pass in the OS engine image. So first we want to check Landsat, right? Once you get all the image properties, we can use the .get info to print out. Let's hit one. Take a look. Similarly, right now you have the property names. You also have the value. This one only has the property names. It has no value. So for example, in here, cloud cover 5%, right? Cloud cover length 6%. Next, let's go through the system start and end. You see from here, now we have this one, 2013, April 9th, and also hour, minutes, and seconds. So this is much like easier to read compared to this one we get from here, right? But you can always format in whatever you want. So in addition to the time start, I also add another property called image date. Okay, so image date, just the date without the time. But you can either use this one if you want like more detail to hours and minutes and seconds. If you just want the date, you can use this image date, right? So in this case, the image, the length set property, this variable contains all the information for this. And so if you just want to get the image date, right? So this is the object contains all the information. You can similarly use the .get. This one here basically is a dictionary. So this is the key, this is the value, right? So you have this object and then you can get the value by using the key. So if you want the image date, you just .get and then print out. You're so able to get the value. Okay, so now you have this one, 2013 April 9th. And similarly, if you, for example, here, if you want to get cloud cover, you can do the same thing. I'm going to show you here. Add another one, right? Length set props. So this is the variable, and then get from here cloud cover, and lastly .get info 5%. So basically, you can just use this one function, image props, passing the name of the image or the variable, and then you have all the information together for you to use. Also, similarly here, how many bands, right? Band 1, 2, 3, 4, 5, 6, 7, and 11, and also some how and pixel quality bands, and also the ID, for example. You can get everything you need just with using one line of code. Next, let's get some image property about the 1 meter resolution image. Right, so it is the variable, we name it NAIP, NAIP. Right, so in here, we very similarly image properties, and then get all the information. So the NAIP imagery has just a few image properties. So in here, I add the image date. You can quickly see what date of that specific image. Also the nominal scale. So basically is the spatial resolution. So 0.06, 0.06 meter. So this is very high resolution. Also the size, like 507 megabyte. How many spectral bands? Name, the unique ID, system ID, and the time when it start, end. So you can get all the information quickly using this one function. You can, similar to the example of, about length set, you can also get just one specific one. For example, you want to retrieve the nominal scale from this dictionary, you just .get and .get info, so then you can get the information. Okay, so this is how you can get all the image properties all at once. Next, I'm going to show you how to compute some descriptive statistics. For example, if you have an image, you want to figure out what's the minimum value of each spectral band, what's the maximum value, what's the mean value, standard deviation, and sum. So you can use this function, image stats, and passing the name of the image and you can also pass in the scale. So in here, the length set is 30 meters, but I'm set this one to 90 just to make it faster. You can use the original one maybe if you want. So let's hit one. It might take, you see it's pretty quick, 30 meters. If you see from here, the image has 7 spectral bands and also 10 and 11. So we calculate the maximum. So that means you have the maximum and then you have the dictionary. So this one contains the information for each descriptive statistics. In here, B1 7624, that means the maximum value of band B1 is 7624, B10, B11. So this is for one maximum. How about the mean? Mean is from here. That means the B1, the band 1, the average spectral reflectance, the surface reflectance is 373. But you need to actually divide it by 10,000. So it's 0.003, right? Also other bands. If you see here, band 5, this is the near infrared band, so it is much higher. So 0.19, basically 19% surface reflectance. Similarly, minimum, standard deviation, and also the sum. So you can get all the information all at once for this specific image in here. So this is the one we are calculating. Calculate the mean, maximum, sum, something like that. Similarly, we can do that for the NAP imagery, 1 meter resolution. Again, I'm setting this one to 10 just to get results faster, but you can use 1 or 0.6 if you want. And just hit one, very quick. For maximum, B blue band, green near infrared, and red band, right? And then the minimum, maximum, something like that, very similar. You can also, this is basically calculating the statistics for the entire image. If you just want a subset of the image, you can also do that. I'm going to come back to here just to show you. For example, if you're trying to calculate the Landsat imagery, you can draw a rectangle. So let me draw a rectangle in here. We just on this area. So how about this? We want to calculate the descriptive statistics of the image just within this area. How can we do that? Once you draw the rectangle, we can actually figure out the rectangle. So if you use the map.user RI, so this one is the geometry of that rectangle. So once we get that rectangle, we can so this is the Landsat imagery, right? You do the same thing. So with this one, copy this one, and then from here, the same. You need to pass in the variable, the image. You can hit Shift tab on your keyboard, and you will see here. Basically, we have two arguments that we can pass in. We can pass in the scale, but we can also pass in a region. So the region is the RI that we just did. So we can type region, and then all we need to do is just pass this user RI that we just drew, and then comma. Then we can hit one. Or we need to, at the end, we need to have .get info to print out the results. Okay, so now you have this one just for that specific region of the image. You can certainly compare this one to the entire image. For example, B1, the maximum is 5832. If you compare this one in here, right, so the entire image is 7624. So this one is a bit lower, right? Makes sense because you only calculate the statistics for a small subset of the image, not the entire one. And certainly you can get mean and maximum, standard deviation, and sum, right? So very flexible and easy to use. It's just one function, passing the variable name and define the region you want to calculate, also define the scale, the spatial resolution. Origin spatial resolution is 30 meters, so you're going to calculate the original resolution. You can do that as well. You can try it again, right? Now you have the result for 30 meters. You will see the result actually change because all the calculations are based on a certain scale. So if you change the scale, you get a lot more detail. Okay, that's all for this tutorial. If you enjoy this video, please consider hitting the like button and subscribe to my channel. And also leave comments down below. Hope to see you in my next video.